Hi everyone, we're going to graph a polar equation which is Limacon with an inner loop. This is our equation, and notice it has the form r equals a plus b cos of theta, and the a is less than b, but both a and b are going to be positive. So before we graph it, we're going to have to do the test. And for the polar axis, which is the x-axis, we're going to replace the equation with theta to negative in theta. If we get the same equation, then it is symmetric to the polar axis. So we get r equals 1 plus 2 cos negative theta. Cosine is even function, so we can just make that a positive, and we get that it does look like our original equation. So yes, it passes, and it's symmetric to the polar axis. All right, the next one we're going to test is the line theta equals pi over 2, and we're going to replace theta with pi minus theta. So let's do that. I'm going to put a little line here. So I'm going to take my equation, r plus 2 cosine of pi minus theta. Now what I'm going to do is use the difference of cosines here, and what I'll get is, it's not r, sorry, I wrote this down wrong. It's r equals 1 plus that. So we get 1 plus 2 cos of pi, cos of theta, plus sine of pi, sine of theta. We know that sine of pi is 0, so 0 times sine of theta is 0. And what we're going to get is 1 plus 2 cosine of pi is negative 1 times cosine of theta, which yields 1 minus 2 cosine of theta. So the test fails. It does not look like our original equation here. So basically it's not symmetric to the y-axis, or the line y at theta equals pi over 2. Now the last one is the pole, and if you've been watching the videos, you know that it's going to fail because my r is just singular. So basically you're supposed to replace r with negative r. When I do that, I get negative r equals 1 plus 2 cos of theta, which does not matter. So all that means is it may or may not be symmetric to the pole. So here we go. I went ahead, since the test passes for the polar axis, I based my table based on the x, meaning going from 0 to pi. So I'm going to graph on top from the quadrant 1 and quadrant 2 because it's symmetric to the x-axis. And I already did the table of values here to save time. And there's my key points I want to graph. So here we go. We try to graph this. I'm going to go start at pi and work backwards to 0. That's how I do it. You can do it another way if you want, but this is how I do it. So basically, pi goes to negative 1. So if we go to pi, there would be 1 right here. But negative 1 means we go in the opposite direction. So there's negative 1. That's from graphing, all right? And then we have 5 pi over 6, which is right here. That's going negative as well, so it's going to be on this side. Negative, little less here, so little less than 1. So I'm going to put 5 pi over 6 is right here. Right about there, very close to negative 1. And then at 2 pi over 3, we're at 0. So we're right at 0 here. And then at pi over 2, we are at 1, which is here. And I should have made this a little bigger. Maybe not. And then at pi over 6, wait, did I skip on pi over 3? we're at 2. So I'm going to go out 2 here. And then at pi over 6, we're close to 3, 2.73. And then at 0, we go all the way out to 3. So it's kind of like this. All right? Now, to do the reflection around the x, I'm basically going to go, let me do it in red. We're going here, then a little bit inner here, then to the origin. So it's going to go loop around this way. And then at the 6 mark, we're a little close to 2 point, yeah, a little close to 3. And then at pi over 2, we're at 1. So it's going to be, we're at 2 mainly. So this is going to be at 2. So it's going to kind of come around here and go around like that. So that's your inner loop. All right. Sometimes it's easier to kind of just do it freehand. All right. So there's your Limacon with the inner loop. Some of the information you need to know about it. It's characterized by these equations where A and B are both positive. This will be helpful because in another video we're going to have to recognize what kind of polar equation it is. And A and B are both positive, but the one with the inner loop, A is less than B. The one without an outer loop, A is greater than B. Also, the graph passes through the pole twice, but it's not symmetric to the pole. Okay, thank you and have a nice day. Bye-bye.